Welcome to today's video. Today we're going to be focusing on finding the domain range, x and y intercepts, and zeros from a quadratic equation. Again, we're going to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out an extra sheet of paper and that way we can get you a fresh one tomorrow. Now, when we talk about domain range, zeros, and intercept notes, the biggest thing we need to keep in mind, it always needs to be in standard form. And you'll either see it written as y equals or f of x equals. Either way, that is the same thing. Y is just a different way of saying f of x. Now, the graph is called a parabola, and there's going to be two different types of parabolas. There's going to be ones that face up, and there's going to be ones that face down. The vertex, and if you look at the arrow, is the point where the line of symmetry meets. So it's our middle of our graph. Now, to be able to tell whether our graph is pointing upwards or downwards, if A is a positive number, doesn't matter if it's greater than 1 or if it's 1, as long as it is positive, it opens up like a smiley face. If we look at our first example, A equals positive 1, so it opens up. On the opposite, if A is negative, then the parabola opens down. Here we have A is equal to negative 1, so it faces down. Now, the axis of symmetry is the vertical line that divides the parabola into two equal parts. We're not going to spend a whole lot of time on that this unit. You'll see more of that in Algebra 2, but we still want to be introduced to it to know that our parabola can be cut into two equal parts. Now, where it cuts through them is called our vertex. If we have a vertex that is the lowest point, it is called a minimum. If the vertex is the highest point, it is called a maximum. And those kind of go together. But if you think about a minimum, that means our graph is pointing up. So my vertex is my lowest point. Where a maximum, my A is a negative and it is pointing down. So we need to make sure we keep that in mind. Minimum does mean it's facing up because it's the lowest point. If we look at our first example here, we have our graph and we want to find the vertex, the domain, the range, and the zeros. Now, for our vertex, it's going to be where our graph cuts in half. It's our lowest point. In this case, our vertex is also our minimum. Well, if I look, it cuts it right there, which is a point, -2, -5. Now, keep in mind, and if you need to, make yourself a little note, domain is all your x values, where range is all your y values. These are only the values the graph hits. For our domain, keep in mind the top of our graph has arrows, so it's going to continue on and on. So my domain, x is going to be all real numbers. It will hit every single x value if we keep extending the graph. The range, however, is the y values. Well, if I look and I take a line and I draw it across my graph, well, we don't want to move that. If I move it and I move it up, it still hits everything. However, if I move that line down, 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 it stops. And it stops at -5. There's no more points that it can hit. So in this case, it's hitting everything greater than or equal to -5. Because my vertex is a minimum, my range has to be higher or greater than the number. Now, for the zeros, this graph isn't the best to look at zeros, and we'll talk about how to use your calculator to find it. But for zeros, what I want you to notice, in this case, there are two solutions. And my two solutions are right here and right here where it crosses your x-intercept. So make sure in this case, we can't tell exactly where they are. They're going to be decimals, but make sure you realize that it's where it crosses your x-intercept. If we look at example 2, again, my vertex is going to be where it cuts it in half. So it's going to be there at 3, 4. And in this case, my vertex is a maximum. It is the highest point. My domain, again, is all real numbers. It hits every x value if we were to keep extending it. My range, if I were to draw a line again, and I drag it, well, it hits all the negative numbers, but then it stops at 4. So it's going to be a value of 4, but if I look, my graph is pointing down, so it is less than or equal to 4. It hits all the y values that are less than or equal to 4. Now, roots is just a fancy way of saying solutions or x-intercepts or zeros. If I look, I want to look where it crosses my x-axis. My root's going to be 1 and 5. If I had given you the equation to factor, it would be the same answers that you get out. If we look at example 3, again, the graph is off-center, but we can still find all our answers. My vertex cuts it in half, so my vertex is going to be 4, -1, and in this case, it is a maximum point. My domain, and I'm going to write it a little differently this time. I'm going to say -infinity to +infinity, just a different way to say all real numbers, but I want to make sure you see it. My range, because it's a maximum point, I'm going to say y such that y is less than or equal to -1. -1 is the maximum it can go on the y-axis. Now, for x-intercepts, well, if I look, it doesn't cross my x-axis. So in this case, there is no solution. There are no x-intercepts. In this case, this is our prime equation. We cannot factor it. If we look at example 4, my vertex cuts it, and it's going to become the point -1, 0, and this is our minimum. My domain, again, it still hits all real numbers, or -infinity to +infinity. My range, because it is a minimum, this is saying y such that y is greater than or equal to 0, because that's my y value. Now, my solutions, it only crosses the x-axis at one spot. So that means I only have one solution, and that's going to be -1. This would be when we factor our quadratics and we get two of the same factors in parentheses. We only have one solution. If we look at example 5, my vertex cuts it in half, so I'm at the point -3, -3, +4, and that is a maximum because my graph is pointing down. My domain is all real numbers. My range, because it's the maximum point, y has to be less than or equal to 4. And in this case, I have two zeros. I have a 0 here and a 0 here. So my zeros, or my solutions, are -5 and -1. Now, our last example, example 6. If we look, that's where it cuts it in half. And it is on the y-axis, and that's okay. So my vertex is 0, -4, and that is a minimum. My domain is all real numbers. My range, because it's a minimum, y has to be greater than or equal to -4. And in this case, it's asked for the roots. Well, I have two roots, two spots where it crosses the x-axis. So I have it at -2 and +2. Being able to understand a quadratic graph is very important because it does give you a lot of the information that you need, and we can get that from factoring, but it's just another method to get the same answer. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.